maybe say a little bit about why I call it a two Hilbert space of a particle. So we have this category. It will actually be what's called a semi-simple abelian category. Every object will be a direct sum of certain objects that you can't decompose as direct sums any further. That's roughly the idea. And those simple objects, they're like the basis vectors. So there will be n of them if this is equivalent to Hilb to the n. And they will correspond to different kinds of particles. So the idea is that if space looks like this, so right, it will be a two-dimensional manifold with some boundary. So these are holes here. So it's a two-dimensional manifold whose boundary is here, in this case, 3 circles. Then you can think of that space as a cobordism that goes from a disjoint union of circles to the empty set. That might be easier to imagine if you drew it like this. So here are some circles, and then here's some two-dimensional manifold. Okay, so we think of this as going from a disjoint union of circles to the empty set. And then because our TQFT is a functor, it will go from z of sigma will go from z of this to z of this. Because the functor z is monoidal, it will take disjoint unions to tensor products. This is an empty union of circles, so it gets sent to an empty tensor product, which is just Hilb. So we get a linear functor from H tensor n Hilb. So what that means is that if I pick some simple objects, say, or indeed any objects, but simple objects, I1 through In in H, it will map their tensor product, which will be an object in here, to a Hilbert space. So what I'm saying then is if you take these circles and you label them with simple objects, you get a Hilbert space. So a Hilbert space in physics means the set of possible states of a physical system. So we're saying that as soon as I label these circles with simple objects, then I know the possible states of the universe, if this is our universe, our little universe here. So it's good to think of those simple objects as kinds of particles, because then what you're saying is that if I think of these things as actually particles, and then if I know what kind of particles they are, I will know what the Hilbert space of states is for a little universe with those kind of particles in them. And it really works. I mean, you really can develop this analogy further and show that these particles act like particles and so on. Now, let's see. So in some ways I'm going too slowly, and in other ways I'm going too fast. I'm going too slowly, and then I may not cover all my material, but I'm probably going too fast because I'm not explaining it well enough. So you should just, I guess you can even tell me to go faster if you want. Usually people will have enough trouble even saying to go slower, but you can regulate the speed by interrupting me.
It's okay.
Okay, so it's not too fast, not too slow. So I'm very interested in the situation in 4 dimensions. So then then it gets harder to draw, but instead of the one sphere as a very simple example of something that would have a 2 Hilbert space, it would be a 2 sphere. And so we'd have a 2 Hilbert space of a particle for a 2 sphere. So it's harder to draw this because we're living in 3 dimensions. But you can imagine we're living in a 3-dimensional manifold, and it has some little balls removed from it. That's like the little discs I removed in the previous picture. I'm just taking this picture here. right? And I'm increasing the dimension by 1. So now we're in a 3-manifold. There's some tiny little balls removed from it. They're so small that they look like particles. They're like points, essentially, almost. And if we label them with some names, or objects in some category, we'll be able to talk about the space of states of our universe with these particles in there. This won't give us a physically realistic theory. This will give us a topological quantum field theory. That is a theory that would apply if you didn't know how to measure distances and angles, but all that mattered was the topology of the universe. And you'll also have other kinds of 2 Hilbert spaces, because now that we're up in one higher dimension, you could also imagine cutting out little solid tori as well. So there'll be other kinds of things besides point particles, and these things will actually act like strings, like a closed string or a higher genus thing called a string network. But let's just think about particles. So ordinarily, when physicists are studying collections of particles, they use an idea called Fock space, which is a Hilbert space, that has certain operators on it which describe the creation and annihilation of particles.